Yeah. And there's this add buffer stuff. Huh. Okay. And this is where the growing happens, right? So I think we want to do something in this add buffers call. So in this add buffers call, this is when we just add the sound. These are sound buffers that we're adding to the rear. And yeah, do I have a picture of that? If I don't, I should, because I need to draw one for myself. Okay, yeah. This was the last thing we were working on. That was a hard problem. Oh, I didn't save it. Save. No, I don't need that. I'll never need that again. Yeah, this is our noise gate. So we'll need a new one. Well, basically, yeah, when somebody says something, the sound will look like this. It starts off at 0, and it goes like that, you know, and then maybe it's just a couple words, so there'll be some humps. I want the object that comes out to look like this. So what we can do, and these add buffers get called like this, and the actual buffers are maybe like they're standard grids like that, you know. Maybe there's 3 per add buffer or 5. It's not set. But so what we can do is while we're growing it, when we add the buffer to the entity, we just note what the amplitude is. Yeah? We note what the amplitude is, and we use that to control the size, the width of the object popping out. So we will need to do a few modifications, because if you look in input manager.h, which is where our buffers are defined, we don't have an amplitude component yet. And the crappy part about this is pretty crappy, is that we have 2 formats for buffers. One uses this Apple audio buffer list, and the other uses our own format. So that means this behavior will be hard to make work for both. Yes, this is where we could start to refactor things a bit. Yeah. Yes. This does suck. Let me do a quick search and see how prevalent that code is. So I think buffer is good enough. So looks like it is used everywhere in filter audio mm. That's not surprising, but that's about 20 lines. And input manager is also where it gets used. And input buffer sound. Then there's these other calls that aren't really related to sound. Not really sure, but the reason we're keeping the audio buffer lists around is because we get them for free coming out of the callback, the sound input callback. And I don't think it's worth converting it and then using our own native buffer. That's a little bit of a waste for me. So what I'm going to say is that I'm just going to, for now, I'm just going to add a float for power. And I'll just say average power. Looks like we're using camel case here. I wish we weren't. I don't know why host timestamp uses camel case. Okay. So, I'm going to now go back to, I'll go to Input Manager. Looks like we won't need voice, no, we won't need mic entity. So if I go to Input Manager, where is that? Yeah. Yeah, whenever I analyze a buffer, actually I have to go to create. There's a function where I return input buffers, so let me look for that. Because that's where the init happens. Maybe I don't. Could have sworn that I did. Okay, well anyway, I guess we malloc them, so we don't need to do anything special. Well, this is what we do. In buff average power equals 0 points f. Okay. So what we have to do is, once we compute that power, and we do this in this analyze call, this is where we have it. We just set that buffer to contain this new knowledge. Yeah. And one of the main, yeah, you can see here, our buffer list is also called buffer, and that has something called buffers in it. An array of one item. So this setup isn't, it's kind of confusing if you don't look at it for a while and you come back. That's why I'm making a little effort to program at least a little bit every day. Yeah, because that whole website move thing really took a toll on me. Okay, so now I've got this average power here. So this is eventually going to come to the voice entity through this call. Yeah? So now the thing is, all we draw right now are straight up rectangles. I mean, they're like real rectangles like that. Let me use a different color. That's the only thing we draw is straight rectangles. And we want to draw these funny looking curves that depend on a bunch of values related to each of these blocks. So if we just use the values directly, we would get some, I mean as coordinates, we would get some discrete, that's not right. We would get some discrete thing that would be the averages like that. And it would look chunky. And this might be kind of cool. This is, you know, poor man's 8-bit aesthetic. The non-artist 8-bit aesthetic. It's kind of fun even just to draw like this. Yeah, but this kind of thing we could do with an array. So we could use another thing I have to mention is that, so when this is coming out of our mic entity, this thing grows at some rate that's not necessarily, it ends up on average being related to the number of bins, number of buffers, because they're both constant. The number of audio buffers is a set number of times per second, and the number of the speed at which we grow the visual y-axis of this object is also constant. but they don't happen at the same time. So if we base this quantization on the y-axis, what we'll get is the shape that grows and shrinks and stuff, and that's not good. It might be okay, I don't know, but the way to fix it is to just say this many pixels will be the first bin, this many pixels will be the second bin, and so on. Yeah. So if we do something like that, if we do something like that, you know, the other thing is to make the size adjustments only happen when we add the buffer. That could be cool. I would be into that. Yeah, what do you say we do that? That's kind of cool, because that'll fix a lot of problems. So you see what we're doing right now is kind of a hack. In where was it? Yeah, that was actually in the update call of mic entity, I think. Oh, I just saw it. Add size. Add size. Yeah, right here. Yeah, see, this is just grows at a constant rate, hard coded to one unit per second. So we can take that out. Can I just take it out? Let me think about this. I can take that out of that one and add that here. And it won't be based on time, and that will be the magic. See, this is using the time step. But if we just here add some amount, and we can hard code the top to say, we can have a member variable, but first we can hard code something like pound define k height per. That was my German influence from studying German for 2 years. Height per buffer. I don't know if I can even say that in German. Height per buffer. I can't remember what height is. Hochheit? Hochheit? Wie groß? Yeah. Anyway, that's not interesting. I'm sorry that I even mentioned that. Let's program. Height per buffer is 10. No. Okay, there's about 40 buffers a second. Yeah. Height per buffer, and we'll just say it really should be height per sample, but you know, let's just be cool and call it something like that for now. So if there's 40 per second and 1 is pretty big, so the thickness of the small walls are 0.2. So 40 of these would be 0.4. I think that's reasonable. We'll try this. Yeah. So right here is when we can change the size and add buffers. We can just do this. Yeah, and that's a vector, so we can just save it till the end. So what I mean is we will need a filter 3 vec. Which is our 3-dimensional vector. Are we only interested in the y? Yeah, this is a design decision that things grow upwards. We'll see if it holds out. So yeah, there's a time step. That we don't have anymore.